Ah, dear Tim and Moby, where does wind come from? From hope. Well, that's one way to move air, and that's just what wind is, moving air. But there's no giant propeller pushing wind around the Earth. Believe it or not, the wind is caused by the sun. If you've seen our thing on seasons, you know that the tilt of the Earth causes some places to be hot or cold at different times of the year, and other places to be either hot or cold all year round. The uneven heating of the Earth's atmosphere is what gets air moving. The sun heats up the Earth's surface, warming the nearby atmosphere. Warm air is less dense than cool air, so it rises. That leaves some empty space, and cool air from nearby rushes in to fill it. The area of rising air is what weather reports call a low-pressure system. As the warm air rises, it cools off and eventually sinks back down. The system is like a big engine sucking in air from all around it. What you end up with is a whole lot of moving air, and that's what we here at BrainPop like to call wind. There are different types of wind that blow in different patterns. Prevailing winds blow all the time over a particular part of the world. They're constant because the equator always gets more direct sunlight than the poles. Warmer air at the equator creates a huge low-pressure area, which is filled by cooler air from the poles. Their direction is affected by the Earth's rotation. Winds in the northern hemisphere are deflected to the right, and they turn to the left in the southern hemisphere. Jet streams are strong winds that blow about 10 kilometers above ground. They blow in circles with one jet stream over each hemisphere, and they blow fast, up to 200 kilometers per hour. Jet streams can move big chunks of air and really affect weather. Trade winds are mild, constant winds that blow towards the equator from the northeast or southeast. Where the trade winds meet, there's a calm area called the doldrums, where there's hardly any wind at all. Local winds are particular to certain countries or areas. Geographic features like mountain ranges or bodies of water can drastically affect wind conditions and create localized winds like the Santa Ana winds in the North American Rockies and the Föhn in the European Alps. Wind power can be harnessed to make electricity, which you can learn about in our Energy Sources movie. What are you doing? What do you mean you're trying to break wind? You can't break wind. It's made of air. What?
All right, so this particular video is going to go over your winds in the atmosphere notes. So just follow along with me and you can fill out your set of notes. If you have the paper version, then you're going to fill it out on your packet. If you are online and did not receive the packet, then you can actually fill these out in your doc while I'm going over them with you. So wind, what causes wind? So wind happens due to changes in density and pressure. When air is heated, what happens to its density? Well, when air is heated, the density becomes less. I'll change that to blue so that you can remember that's what you have to write. So what will heated air do? Heated air rises. So the kind of pressure that's left behind is going to be low pressure. So if I could show you, there's an instance where you can actually fill up a balloon, okay? The air inside a balloon, once you fill it up, becomes very high, and the area outside of the balloon is very low. So the way that wind works is that it's going to go from an area of high pressure to an area of low pressure. So that's why when you let go of a filled up balloon, the air immediately goes out of the balloon out to the atmosphere. So that is how wind happens. It goes from an area of high pressure to an area of low pressure. So the air that's left behind, that when warm air leaves, is you'll leave behind cool air. So rotation of the Earth actually affects how winds travel. If you did the wind station lab, you should have noticed that when you actually did the turntable activity, which was station 1. Every time you tried to draw a straight line, the turntable forces your line to actually curve. So with that being said, there's different types of winds that occur throughout the world, and these are going to happen all throughout, okay? So this curving of the winds create what we call convection cells. It happened every 30 degrees latitude. So for those of you who don't remember what your latitude is basically the horizontal flat lines. I always try to remember latitude is flatitude. So the equator is 0 degrees latitude, and the next line after that is 30 degrees latitude. So if you go up, it's 30 degrees north. If you go down, it's 30 degrees south. And the one after that is 60, and then the very top is 90. So the North Pole and the South Pole. North Pole is at 90 degrees latitude north, and the South Pole is at 90 degrees south latitude. Okay, so at every 30 degrees, you're going to have these convection cells, and they cause the rising and sinking of air from the north into south. This is what we call the Coriolis effect. Okay, so let me show you a little video clip. Here is this gentleman right here. He is actually going to, and I'm going to play the video, and I'm going to actually narrate the video for you. So here he's got a flat disc, and if you notice, the disc is not moving, and he places the ball in the middle of the disc. When he lets the ball go, the ball just goes back and forth in a straight line. Okay, he even points it out in the video. Now he's actually going to take the disc and rotate it. He's going to rotate it in a counterclockwise manner. Okay, that means it's going the opposite direction an analog clock would go. And when he puts the ball into the dish, at first you would think it's going back and forth in a straight line, but really, using the camera that he mounted at the top, he actually monitors the ball itself. And he noticed that the ball is not going back and forth. It actually is going in a circular pattern. He's actually pointing out to these video screens because they actually draw out the pattern of the ball. And you'll see here that, again, the ball does not go in straight lines. In fact, it goes in circles. You can kind of see that circular motion there. So, of course, it's better to have more than one video to support this evidence. So we have some gentlemen who are on this type of seesaw type active plane. Okay, I'm going to play its video. Same thing. I'm going to actually describe what's happening. So not moving, they actually take the ball and they throw it straight at each other. And it's great. They can catch the ball because it goes straight at them. Okay, back and forth. But now they're going to actually rotate the platform. And again, they are trying to throw the ball straight at them. But what ends up happening is the ball does not travel on a straight path. The ball actually curves. To prove that, they actually did a frame wherein the camera's mounted on the top and they look down, and you'll notice that the ball, again, when you watch it, it actually goes in a curved manner. He's still trying to throw it straight, but it curves. Notice again the curving. And notice also that the curve is actually the opposite direction of the rotation of the platform. Here, you can watch it with the rotating frame. The camera's mounted to the rotating platform. So much faster in this situation. I can't watch it because it makes me dizzy. But here in slow motion, again, you can see the ball is curving. The next one is actually even more interesting to see from the point of view of the person. So again, throwing the ball at you. But watch what happens. Again, the ball cannot come straight at you. When the ball comes toward you, it curves. And if he was trying to purposely curve it, then you would see that curve immediately, but you don't see the curve immediately. You see the curve happen after a little bit. And here you notice that, again, if you rotate the platform in the opposite direction, the ball goes in that direction. Okay. So back to our notes. So because the Earth rotates, wind cannot move straight toward or away from the equator. In fact, winds turn in the northern hemisphere counterclockwise. This actually affects a lot of our storm systems. In fact, hurricanes get affected by this. So in the northern hemisphere, storms rotate counterclockwise. In the southern hemisphere, storms rotate clockwise. So moving on, we actually are going to talk about different types of winds. These are called prevailing winds. These are winds that travel all over the globe. And these winds are really, really important because these are the winds that actually move entire storm fronts, such as hurricanes and tornadoes. Not so much tornadoes, but more hurricanes or big, huge um, storm systems like the ones that create snow days. Okay. With that being said, there are some winds that stay in certain areas. So we're going to actually label these types of storms. So, okay, the first type of wind, the global winds we're going to talk about are actually called trade winds. And if you look at the definition, global winds on Earth blow over long distances. And there's three main ones that are going to concern us. Technically, there's four. Okay, trade winds blow from the west, from the east to the west. Okay. These trade winds are really, really important because they were named after the winds that actually were used by sailors, and they are still used today to help transport any goods or any type of major materials from one continent to the next, specifically from Europe to Africa and to North America. So sailors would actually require the routing of these winds so that they knew that if they got on one of these trade winds, that it was much easier to travel from one point to the next if they were actually able to catch one of these trade winds. Okay. So trade winds are responsible for moving storms and hurricanes across the Atlantic toward the Gulf of Mexico. Sometimes we'll get some certain particular times a year where the trade winds won't move as normal as they do. So in those times of the year, okay, and this doesn't happen every year, we call those El Nino winds. So when we have those types of winds, our weather isn't very typical, such as California, instead of it being a hot, sunny climate, it'll actually experience like a wet fall and winter type weather. So yeah, that's when California actually gets pretty darn cold. So if you were labeling this on your paper, okay, these trade winds would actually go in letter C. So you want to label trade winds right here in letter C on your diagram. In letter B, you're going to label these another type of global wind, and they are called westerlies, and that is where number 2 is, okay? These are westerlies. And these are winds that are named from the direction they blow. So in other words, they are westerlies, so they travel from the west to the east. And these are really, really important because these are the winds that our storm systems travel on so that we know what's going to happen in Ohio. So what ends up happening is in order for me to look at any weather that's going to come in for like an hour from now, I'm always going to look to the west. Okay, so in an hour from now, I want to look at places like Indiana. And if I want to look at the weather for tomorrow, I'm going to look further west. So that would be like Illinois, okay? So for our weather in Ohio, we always predict weather that comes from the west that travel on the westerlies will help us figure out the type of weather that'll happen for tomorrow or an hour from now. So that's why we were able to figure out what are the chances of having another snow day, okay? The third type of global wind, which we'll put at letter A on your diagram right here at the top, okay, is actually called polar easterlies. So just like westerlies, they're named from where the winds come from west to east. Easterlies move from east to west. And the kind of air they're going to bring is actually within the name, polar. Think polar. Do you think warm or do you think cold? Well, hopefully when you think polar, you should think cool air. Okay. Now here in this diagram, you're going to see a fourth type of global wind. And this type of global wind happens everywhere around the world, okay? These are called jet streams. These are high bands of wind that move polar air south and tropical air north, okay? So if you were to have a jet stream that was coming from the north and dips south, what kind of weather would that bring us? Well, if it's coming from the north and going south, that's going to bring cold air. Okay. So in your letter A on your diagram, you're going to want to label this one a polar jet stream. So if you had a subtropical jet stream that moved north, so in other words, a jet stream that came from the equator and brought weather up north or winds up north, the type of wind that you should receive is bringing in warm air. So here in letter B in your diagram, you're going to label this one a subtropical jet stream. I know that's a small box for a lot of it, so you can write all over on it. So if we have global winds, that means that we must have something called local winds, okay? So let me show you a wind pattern map. And you probably have seen this before when we did our wind station activity. So this is the winds that are going on right now on February 9th, 2021. Okay, if you're watching this video at a different time, then this might be out of date for you. But this is a pretty accurate wind map, okay? This actually updates itself every day in the mornings. They actually download it and they tell you what time it downloads. So here you can see Columbus is here. We are a little bit south of Columbus, right around here. If you're actually looking at this map and watching this on February 9th, you'll notice that the winds here are not very strong. And if you actually looked outside right now, the winds really aren't that strong. In fact, if you hover over it, the winds are like at 5 miles per hour, which is very, 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 very low winds. Here you can actually see what that looks like on the left-hand side, these different icons. Up north here, they actually have a lot of windy storms going on right now, specifically snowstorms. So they're getting 30-mile-per-hour winds. Here you can see in Dallas, which is actually part of what we call Tornado Alley, they tend to get a lot stronger winds. So hence, that's why Dallas and areas that are along this line going up north, this is called Tornado Alley. They get a lot of wind systems that are very, very strong. Hence, they get a lot of tornadoes. Okay, actually, it goes this way. We are on the edge of Tornado Alley. If this was a different type of year here in here in Florida, you would actually see stronger winds in Florida due to hurricanes. So these are local winds. These are winds that stay within our area. There are two types of local winds. Okay. We don't get much of this type of wind. These are called sea breezes. And again, if you remember, winds are named after where they come from. So a sea breeze comes from the sea or the ocean. Okay. Heated air over the land will rise. And then what we'll do is we'll leave behind an area of low pressure. So this cold air right here will be left behind. So this will be cool. This letter A here will be labeled as low pressure. And letter B here will be labeled as high pressure. So remember that ground has a lower specific heat than water. When would the air over the land be warmer than when would the air over the land be warmer than over the water? Okay, and that would be during the day. So that's why if you actually go to the beach, okay, and you step into the land or on the water, you'll notice that the air that comes in is pretty darn warm. That's because you're going to have warm air rushing onto the land, pushed by the sea's cool air. unlike land breezes, which obviously they come from the land. In this case, the heated air over the water will rise, so it's going in the opposite direction and leave behind low pressure. And the cooler, drier air over the land now will fill the rest of space. So now you're going to have the warm air leave the land, and cool air will be left behind. So at night, this is why the air is actually warmer at night near a sea. Okay, so that's pretty much the end of your notes for winds. So the next set of notes will be on ocean currents and then on climates.